Welcome. Glad you could join me. Today I'm going to demonstrate for you how to chart a forecast in Excel. My name is Dr. Stephen Herod, and we are working in Excel version 2007. So most of what I show you will be identical if you're working in an older version of Excel, but just to be aware, the menus that you see above are for the version for 2007. So let's get started. Here's what we're going to do. First of all, we're working with a simple exponential forecast today. So I'm going to show you how to program the formulas for a simple exponential forecast into a data set on the next spreadsheet here, on the next tab. Then I'm going to show you how we're going to study this forecast to see how good it is. We're going to do some analysis on this forecast. So I'm going to show you how to calculate the mean absolute deviation. I'm actually going to go straight to the running mean absolute deviation, which is a little bit more advanced version of the mean absolute deviation. And then I'm going to show you how to calculate the running sum of forecast errors. And then I'm going to show you how to calculate what's called the tracking signal, which is a way to diagnose the process that you're forecasting and look for any patterns or look for any indication that the process that you're forecasting is undergoing any significant changes. Finally, we'll graph the forecast and we'll graph the tracking signal and discuss the results and do a little bit of analysis. Okay, well, let's move on to our worksheet. Here's our workspace, and we're starting here. We've already got some data. This happens to be some fuel consumption data. This is the mile per gallon figure for a family car. And these are data entries made every time the gas tank has been filled on the car. So every time the gas tank has been filled, the fuel consumption, the number of gallons purchased has been recorded, the mileage has been recorded, and we've calculated the miles per gallon for that filling. And then the time column there is simply the sequence, the serial number of the fills, the fuel tank fills for this car. And you see we have about 129 data entries here. We have 129 fuel tank fills for this car. So if you fill that car, I don't know, once a week, so we have about 2 years of data here. So let's start by making the exponential forecast. Now the exponential forecast has one parameter that we have to set. That parameter is called alpha. So we should put on the spreadsheet a place where we can simply change alpha or enter alpha to make it a lot easier for us. So let's go ahead and do that. Let's put a label in first. And let's use this cell to record our alpha value. So let's put some cosmetic decoration here to help us keep track of where alpha is on the spreadsheet. Line this up. I'm going to do something special. I want to name this cell to make it easy for me to recall this information in future formulas. And the way I do that, I highlight this cell, I go up here in the left in this area called the name box, and let's name it. Let's just call it alpha. Type the name in and hit the return key. It saves that name, and now that name is linked to this cell right here. And you can always go back and check to see if that name has been linked correctly. If you highlight the cell like that, notice the name has now popped up, verifying that you have in fact named that cell. Okay, let's go ahead and put in our forecast. Here's our forecast. Remember, this is our simple exponential forecast. And the formula for a simple exponential forecast, let's put that in right now. That formula is the forecast equals alpha times the actual data. Let me back up here a minute. I started too quick. Move down a cell. Let's put it right there. Okay. Equals alpha times the actual data from the previous time period. That's where I goofed up there. Alpha times the data from the previous time period plus parentheses 1 minus alpha times our previous forecast, which would be right here. And then hit return, hit enter, and now you've got that formula in there. Now recall, for the exponential forecast, we need a seed forecast. We need a starting forecast value to start our forecast. In this case, we don't have any other guidance. We don't have any other information to go by, so we're going to use the simple, naive seed value here. We're just going to use the existing actual data from that day for our forecast. So there we go. So there's our first forecast, really. This value up here was something we just entered as our starting point. Give it a little color to separate it. So that is not a real forecast. That's just an estimated forecast that we put in as the basis for our calculation. This is our first real forecast right there. Now we want to carry that forecast all the way down. We want to forecast all these values down here, all these time slots right here. Since we've entered this equation, let me show you that equation again right now. So that's the forecast equals alpha times the previous time slot's data value plus 1 minus alpha times the previous forecast. Now, since we've entered this with a named cell and everything else is just going to flow, we just want the next equation down to be the exact same equation, but everything shifted down a row. All we have to do is highlight that cell, grab the corner, click and drag. And you drag that all the way down. And Excel is automatically updated that equation and filled it into each row below for you with the correct references. So every cell going down here is now alpha times the previous actual data value plus 1 minus alpha times the previous forecast, and there it is right there. Now nothing's happening yet. It's not a very exciting forecast because we haven't created a data value for alpha yet. So alpha, of course, is any value between 0 and 1. For now, let's just pick a simple value that might make sense. Let's use 0.2. And I enter 0.2, and now suddenly we have some forecast activity. Now we actually see some forecast here. So there it is right there. There's a forecast using the simple exponential. So there's our forecast. Now the next thing we want to do now is we want to calculate our running mean absolute deviation. Now to do that, first we need our absolute deviation. Okay, and the absolute deviation is going to be our actual value. Let's see, it's going to be equals the absolute value of this minus this. The absolute value of our actual value minus our forecast value. So we'll save that. There we go. And in this particular first entry, it's of course practically 0. And then we'll click and drag again and get that value for all of our forecasts all the way down. Now technically this first one really isn't our first forecast because we didn't do a forecast. That was a made-up value. So let's get rid of that. There technically isn't really a forecast right there, so we shouldn't be doing any absolute value calculation right there either. So we've got our absolute deviation, so let's get our running MAD. Let me line up these columns right here. Actually, let's put some more rows over here. Did you see how I did that? If I grab a cell and click and drag, basically the idea is anytime you grab a cell and click and drag by the handle, you're copying that cell's contents up or down, or left or right, depending on which way you drag. So I wanted to get that formatting, so I clicked and dragged over to get that formatting. So running MAD Now we have nothing in the first entry because we're not going to pay attention to that. That's our starting cold start value right there. So let's start right here. So our running mean absolute deviation. So the first value is going to be average times average of this value. Actually, it's just the one value. Now let's set this up so that we want it. The next one we're going to want is going to be average of this and this. Now we can make this a lot easier if I lock in this top cell with a dollar sign. And then, did you see what I did? Let me show you what I did again. So that is the average of this range of cells. Now it's the same cell, so it's essentially one cell. But the first one has been locked in with these dollar signs right here. What that means is now when I want this one to be the average of the first and the second, now when I click and drag, it's going to lock that in, but it's going to update this one. So now I have the average of two cells. And if I do that again, now I have the average of 3 cells. And if I do that again, now I have the average of 4 cells. Do you see where this is going? So let's take this to its logical conclusion all the way down. So this is the running mean absolute deviation. This is the mean absolute deviation of all the forecasts up to the point wherever you stop. So this is that running mean absolute deviation. Here's that running mean. See, it's collecting everything up to that point. You just keep on going. It's the same thing. So now we have the running mean absolute deviation. So the next thing we need is the running sum of forecast errors. Now the running sum of forecast errors. Now the forecast error is the actual value minus the forecast value. So there's our first forecast error. So the running sum is going to be the next forecast error minus, here's a forecast error, plus the previous forecast error. That's the running sum. The sum of all the forecast errors as we go. So there's a forecast error. And we do the same thing again. Actual minus forecast plus previous error, sum of error, like that. And I think you can figure out where this one's going to go. We can click and drag on this too. So click and drag. And now we've filled, everywhere we go, we have filled this equation in properly. Each one of them is the current forecast error plus the sum of all the previous forecast errors. So we have our running mean absolute deviation, our running sum of forecast errors, and now we're ready to calculate the tracking signal. Now the tracking signal is the running sum of forecast errors divided by the running mean absolute deviation. So that's going to be this cell divided by this cell. I'll save that. Here we go again. You know where this is going. Click and drag. Down we go. There we go. So there is our tracking signal for this data. So now we have completed a forecast. We have a simple exponential forecast. We've calculated our running mean absolute deviation. We've calculated our running sum of forecast errors. And now we have our tracking signal, which is the ratio of the running sum of forecast errors divided by the running mean absolute deviation. So let's graph these and see what we've got. First of all, let's graph. Insert. Get a little graph. How about line? Sounds good. Sounds like this one looks good. It's going to give us a dialog here. It's going to ask us to collect some data here pretty soon. Go up here and select the data. And here's our forecast. Let's call that forecast. Let's go ahead and add our actual values in here too. Remember to leave out that first row because that's just that's our starting point, and we don't want to compare that. And we're done. So here's our forecast. Now it looks a little ugly because these data points are so big and dark and black because I've got the screen resolution up so high. But you can manipulate this. If you just get your mouse over that line and right click on it, and then it says format, see it says format data series right there. Let's do that. And you can start to tinker with these markers and make them smaller. Maybe 3 points sounds good. Let's change the size of the line. Much better at this size right here. Same thing with the blue. Let's do that too. I'm still showing the red. No, come on, blue. I want the blue. There we go. Bring that down. Make the line smaller. Okay, so there we go. Look at that. We got a nice graph. And we can have a little bit of fun with this at the moment now. See, we've got all this data, but it's automated according to this alpha value. Now you can experiment with this alpha. Look at this. Watch this. Change your alpha. Look at the line move. Isn't that kind of fun? See how the line shifts? Of course, look what happens when you go to 1. Remember this lesson? Alpha equals 1. What does that mean? What kind of forecast do we have when alpha equals 1? Answer: this is the naive forecast. Alpha equals 1 and the simple exponential becomes the naive forecast. So you can see the blue line is essentially exactly the same as the red line, only it's shifted over by 1 time unit. Go the other direction, go to 0. Oops, look what happens to the forecast. It disappears. We got a flat line. So you go to 0 and essentially our simple exponential forecast means no forecast. Nothing's happening. We don't have any information at all. So that's kind of the range between 0 and 1. So let's put that back where it was. So now let's take a look at our tracking signal. Okay, let's graph that tracking signal. Let me scoot this out of the way so we have some space. I'm going to move that over here. Here's our tracking signal. Let's start over. Insert, graph, 2D line right there. Make some room, kind of shift this around. It's kind of still in the way. Select the data. Move this out of the way again. And here's our tracking signal. Let's grab that. Okay. We're good with that. That's okay. Scoot up here. Let's look at our graph. Now, since there's only one value on this graph, you don't need a legend. The legend is silly. There's nothing to distinguish. So you can just go ahead and delete that. So we're going to delete that. I hit the delete key and made it go away. Okay. So here's our tracking signal. Let's tighten this line up again. A little bit tighter line. There we go. So there's our tracking signal. Now, I'll leave it to you, if this is an assignment, I'll leave it to you to figure out how to add a title to this, pretty it up in some ways. Maybe you want to adjust some of the font sizes and things like that. I'll leave that to you to experiment with. But take a look at this tracking signal. So look what's going on here. You know, it's peaking at certain points. It's peaking right here. Huge swing right here. There's another peak right here. And then it starts to kind of climb up here this way again. What is going on with this tracking signal? Well, something is fundamentally changing in the underlying process when these peaks are happening. And it turns out that what is in fact changing is these are the points where we have summer mileage. These are summer driving mileage. The mile per gallon figure is going up in the summer and during vacation, because we're taking family trips at these times. And so the car mileage is having a dramatic shift. And then here, where this is starting to climb right here, this represents a subtle long-term shift in the car's performance. Tires, air pressure low, maintenance issues. The car is fundamentally starting to change its behavior right along here. But these peaks right here, these represent basically highway mileage. Basically times we've taken the car on a long trip. And as you change the alpha value, these things will start to shift. Look at that, it's starting to shift more there. So you see a different picture with the tracking signal as we shift the alpha value, but the same kind of peaks are still here. And these represent family vacations. These are the fuel fill-ups on long highway trips to family relatives, to places across the country. And then this over here represents the car basically is getting old, starting to show strange behavior as it gets older. So we're done. We started with a sample set of data. We calculated an exponential forecast, a simple exponential forecast. We calculated our absolute deviation. We now have a running mean absolute deviation. Then our running sum of forecast errors, and we calculated our tracking signal, and we graphed our forecast. Here's the forecast graph right there. And then we graphed our tracking signal and did some analysis. So we're done. Thank you so much for joining me on this lesson. Hope to talk to you again. Thank you. Bye-bye.